Hi, I'm Robert Woodbury, and I'm here to present system features in the new D.Star system for interacting with design alternatives. D.Star stands for Design Repeat. D.Star presents as two parts: a parametric modeling system communicating with the D.Star online parallel gallery system. In building D.Star, we used a model of design. Now, there are many models of design. Each describes some structure and process in design, and each has utility, usefulness in certain contexts. Our model of design is the design iterates. It goes in cycles. Iteration elaborates as three parts. Designers make things, they evaluate them, and they reflect on their action in each of the iterative cycles of design. We call such iteration design dialogue. Design dialogue manifests in media. In each iteration, designers produce designs and they view designs. They compare designs, they contrast them, and they edit them. However, current design systems limit us. They allow us to see and edit only one state at a time. Other states are hidden in past interactions, complex layer structures, or stored files. This single-state document model pervades all CAD system designs and precludes effective support for design dialogue. D.Star breaks the single-state document model by giving access to many states at once. Further, it provides tools such as collections for organizing the alternatives designers create in the design dialogue cycles. Each design medium has specific properties. For example, in a sketch, designers can capture multiple ideas on a single sheet of paper. We chose contemporary and quite popular parametric modeling as our medium because a single model can embody multiple design alternatives. We abstract a parametric model into two parts: the model itself and an aspect, a selection of inputs and outputs that a designer intends to work with in the moment. We had several aims in building D.Star. We provide multiple simultaneous designs to support design dialogue, multiple coordinated views to reveal patterns in design data. Parallel editing amplifies designer actions. We built a mixed initiative design so that we can embed generative design in practice. And finally, collections support epistemic actions in work. The abstract design of D.Star has three parts. We have a central online gallery system that interacts with a parametric modeler with which a designer can work and provide input to D.Star, and one or more cloud modelers with which D.Star can work without designer interaction. The D.Star architecture elaborates into a more complex system involving databases, JavaScript, and frameworks such as React. D.Star provides devices such as collections and floating menus to organize many alternatives on the large displays for which it is designed. It provides tools for editing many alternatives at the same time. In this case, we are editing one alternative with a partial sketch that will define new alternatives, but this can be done with many. D.Star provides multiple coordinated views to gain insights from different representations of designs. D.Star enables an entire new suite of mixed initiative interactions with generative design, not possible in the single-state document model. With D.Star, designers can directly initiate and control generative design algorithms. The Cartesian product provides an example. The designer selects two or more alternatives and several parameters. The Cartesian product computes all possible combinations of these alternatives and parameters. User studies have confirmed much of the D.Star design for us. Over 30 demonstrations and interviews with experts confirmed its basic design and revealed patterns of use that are in concordance with design dialogue. A detailed para-analytics study with two experts confirmed and elaborated these exploration patterns, suggested new detailed use cases for architectural practice, and provided many usability suggestions. Here is the D.Star system in operation. We generate two alternatives and send them to D.Star. We copy these to a new collection and view the collection as a parallel coordinates diagram. We sketch a new alternative by selecting an alternative and making a partial input. The new alternative is computed. We select two alternatives, sum of their parameters, and parallel edit them in place. We select two alternatives, again sum of their parameters, and use those to generate the Cartesian product of all parameters in both alternatives. At any time, we can select an alternative and restore it to the modeler. D.Star can work with any parametric modeler. D.Star was conceived and built by the Computational Design Group at Simon Fraser University in Canada. Thank you.